Page 411, we are going to do some reviewing for Chapter 6. So on the chapter test, these first questions we're going to solve by graphing and then tell whether it has one solution, infinitely many solutions, or no solution. So what's going to happen is if we have one solution, the lines are going to intersect in one point. Infinitely many solutions means the lines are the same as each other, and no solution would mean the lines are parallel. So these are what we talked about if we're going to do this by graphing. It's not always the most accurate method, but if I allowed to use my graphing calculator, then that would be a case where I would use that I would graph it. So we're just going to imagine if we're doing these on our graphing calculator. So if you put these both in, y equals, type these equations in, and graph them, then they should look something like this. And then if you do second trace, which is the calculate button, so do second, and then the trace button at the top, it says calc above it, so it's going to be calculate. We're going to calculate the intersection, so calculating the intersection of these two lines, which would be end up being at 2, -1. So this one has, we could say this has one solution. There's one solution that works for both of these equations, and that is the point 2, -1. For number 3, if we were going to graph these, first we would want to solve them for y. So if you subtract x on this first one, you get -x plus 5. Same thing on the second one, you get -x minus 2. And when you graph those, which you may notice this already, they have the same slope, but they have different y-intercepts. So these are going to be parallel, which means this has no solution. These are parallel lines. They don't have any solution that works for both of them. They don't intersect at all. Number 5, it says to solve using substitution. And this is set up nicely for substitution. On your test, I'm not going to tell you a certain method to choose or to use. I'm just going to basically leave it up to you to decide how you want to work this out. So this one has y equals something, so that's going to be easy enough for me to substitute into this other equation. So once we've substituted, we can distribute this. We can combine like terms. Would be -2x plus 2 equals -2. So x equals 2, and now I've got this space over here. I can put a 2 in place of the x. And that tells me 2, -9 would be the one solution for that system of equations. Number 7, if we were going to solve that, this is set up pretty nice as it is, that we could just add these together and the y's would cancel. And even better, it's going to give me 1x equals 8. You can divide if you want, but that's going to tell us x equals 8. And then we can use that to figure out what y is equal to. I'm just going to use that first equation. So if x equals 8, And then that would be negative 24. So 8, negative 24 should be our answer for that one. Number 8. Nothing's going to just cancel just quite so easily as the last one, but if we multiply this top equation by 2, then the y's would be opposites of each other. So x equals 11. And then we could put that in either equation. I kind of like the top equation. No negatives and smaller numbers there. So 11, negative 2/5 would be our solution for that system of equations. And then number 9, this one, kind of think about, it's kind of really, we're getting a least common multiple, which is kind of like getting a common denominator. So with 2 and 3, we could use 6 would be a common denominator, which is really just our common multiple here. With 2 and 5, least common multiple would be 10. So 6 is a smaller number, so I'm going to go with that. And what we need to have happen is they need to be opposites of each other. So this one's going to be 6x, then the other one would have to be a negative 6x for it to cancel. Okay, so that didn't come out very good, but that's how it works sometimes. It's not always going to work out perfectly. I substitute in. Get a common denominator. And then the last step here, you could either divide by 3 or multiply by 1/3, either way. So if we divide by 3, that's the same as multiplying by 1/3. And these, negative 132 is divisible by 3, because 1 plus 3 plus 2 is 6, which is divisible by 3. So that would be negative 44/19. So that one we end up with negative 44/19 and negative 29/19. Number 10, they want us to solve that system of inequalities by graphing. So we would graph both of these inequalities. So first you would, you could find some points that would be on the inequality line if it was equals. There's no fractions here, so if you want to use 0, 1, and 2, it'd be 0, negative 1, 1, 3, and 2, 7 would be some points on that one. On the other one, if you graphed that, would be 0, 4, 1 would be 3, and 2 would be 2. When you graph the lines, they're going to look something like this. And then we just have to think about if it would be solid or dotted lines. So this red line, the negative x plus 4, it was less than or equal to, so that's a solid line. The other one was just greater than, so that would be a dotted line. And then on both of those, we would try 0, 0. So that first inequality, if you tried 0, 0, you'd get 0 is greater than negative 1. And that is true. So 0, 0 works. We would be shading that direction, which would be the dotted line. So we'd be shading this direction. And then the other one is if you tried 0, 0 on it, you'd get 0 is less than or equal to 4, which is true. So we'd shade towards that as well. That's our red line. So 0, 0 was below that line, so we'd be shading there. So in the end then, it's kind of this region over here that we'd be shading. And you can go back and clean up your other spots if you want. It's not letting me get rid of the other ones up there right now, but anyway, you get the idea. Number 12, if you go to a garage sale, all the items are $1 or $5, you spend less than $45, write and graph a linear inequality that models the situation. So $1 each plus $5 each, and it's less than $45. That's our only inequality that we have, actually. If you did intercepts, this would be 0, 9, and 45, 0. And then you would just graph that. When you go to graph this, it's less than, so doesn't include it. You'd have a dotted line. 0, 0 would be an option. If we didn't buy anything, we would spend less than $45 for sure. So this would be an answer for that. And I went by 1s on the y-axis and 5s on the x-axis, so that's why it's looking like they're actually about the same as each other when really they're not. Number 13, a farmer plans to create a rectangular garden that he will enclose with chicken wire. The garden can be no more than 30 feet wide. The farmer would like to use at most 180 feet of chicken wire. Write a system of linear inequalities and then graph it. Okay, so if we have just depending what you use for your variables, I would probably just say we're going to let x represent the width in feet, and let y represent the length Okay, so if the width can be no more than 30 feet, x would be less than or equal to 30. And if they were going to use at most 180 feet, that would be dealing with our perimeter. So 2x plus 2y would have to be less than or equal to 180. On this one, if you did the intercepts, that would be 0 and 90, and 90, 0, which obviously doesn't make sense. We can't just have 90 feet for a length or width and 0 for the other one, but anyway. This one maybe we'll go by tens. So if x is less than or equal to 30, that'd be a solid line. X equals 30 would be a vertical line here. If it's less than 30, that would be going to the left of that one. And then the other one, you'd have 0, 90, and 90, 0. That would be a solid line also. If you try 0, 0, it technically works, so we'd shade below that line. And you can see shading below that, this one part's not going to work. So it's going to be kind of this trapezoid area over here is what would work on that one. And another thing they could have done is asked us to write some different possibilities. So just find ordered pairs that are in there where the length and width can neither one be 0 though. You know, for example, the width is 10 and the length is 50 or something like that. Okay, just make sure the point is for sure in that shaded area. Number 15, this is kind of a mixture problem, so this was where we talked about one way of doing these would be using this container method. So one solution is 30%, one is 50%. We're trying to get a 42% mixture, and that's 200 liters. Okay, so somehow we have x plus y equals 200, and then 0.30x plus 0.50y equals, and that should be 82. So those would be our two equations. If you want to rewrite them, you can. Might be a little neater to look at. This one, if you wanted to, we're not too far off here from substitution if you like that method. And you could either do x or y, it doesn't matter. Distribute. Combine like terms. And divide. I'm sorry, I made a mistake back here. This should be 84, not 82. So that'd be 120 liters of the 50%. And if we had 200 total, that would leave 80 at the 30%. Okay, and then you could check that also with your other second equation and make sure that that works. Number 17, a student concluded -2, -1 is a solution of the inequality as shown. Describe and correct the student's error. And this is a very common mistake. Basically, they switched x and y when they substituted. Y should be -1, x should be -2. So -1 is not less than -5, so that actually is not a solution. So in addition to this, there are other pages you can use for reviewing in your book. There are also things you can look at on the textbook website to help you review as well. So this should give you an idea of what we're looking at in Chapter 6. Have a good day.